This is the In Focus podcast from The Hindu.
Hello and welcome to the In Focus podcast. I'm your host, G. Sampath. Northern India is enduring its hottest ever summer this year, with the number of heatwave days in May increasing by 125%. And as per reports, extreme temperatures in the range of 48 to 49 degrees have killed around 77 people across the country, including 33 who were on election duty in the just concluded Lok Sabha polls. And not only have average temperatures been high in cities like Delhi, which do tend to suffer the quote-unquote heat island effect, temperatures have also been consistently high across a vast region and across a high number of days. So how do we understand this trend? Is this primarily due to climate change, or is this due to environmental degradation, rampant loss of green cover across northern India in recent times? And what are the public health implications of this kind of a heat wave phenomenon, and what is the remedy? We discuss all these questions and more in this episode of In Focus, and we have with us Raghu Murtugudde, Professor of Climate Studies at IIT Bombay. Professor Raghu, thank you so much for joining us and welcome to In Focus.
Thank you, Sampath. How are you?
All good, all good too. So to start with, I just want to ask a very basic question. Is this year's extreme temperatures that we have been seeing from April onwards, in fact from March onwards, across north, northwest and central India, is this a continuation of something we have seen before in earlier years? Or is the severity this year something new, some kind of a departure from the past?
So this year is unusual, but it is on top of what we expect. As you know, sun comes up north into the northern hemisphere after March, and India begins to heat up like a popcorn kettle. And what is different this year, other than that our heat wave season in fact is March, April, May. This year, as you know, we are coming out of 2023, which had record warm temperatures. And we are continuing that into 2024 summer. And this will continue till the monsoon arrives, which has just started, and the La Nina kicks in. So since I'm mentioning La Nina, I should say why 2023 was so warm. But we can wait to see if you want to ask that separately. But mainly, this is the heat wave season, but this year we have added a lot of additional warmth to it.
Okay, we have added a lot of additional warmth. So when you say added a lot of additional warmth, what exactly do you mean? Is this, are you talking about climate change? How much of it is actually attributable to climate change, the excess heat that we're seeing this year?
Yeah, so this is a question that comes up all the time. The way I say it, everything is now happening in a warmer world. We have warmed somewhere around 1.3 to 1.4 degrees, especially into 2023. So all weather events are happening in a warmer world. So all weather events have a contribution from climate change. What is different about 2023 is that it was a El Nino year. And El Nino is a mini global warming. Basically, during normal years and La Nina years in the eastern Pacific around Galapagos, the ocean is cold and it keeps taking up heat from the atmosphere. But when El Nino happens, that heat is belched out. So we get a spike in the warming anyway. This is called a mini global warming for that reason. But what is different about 2023 is that it is much warmer than what you would expect from global warming plus El Nino. We don't have a complete explanation for that yet, but we know that Angatunga was an underwater volcano that went off in 2022 and threw up a lot of water vapor into the upper atmosphere. And water vapor is a very powerful greenhouse gas, so that probably spiked the warming, and we expect that the impact of the Hangatunga volcano will go on for a few more years. The other thing that apparently happened is there's some evidence that maybe the pollution was a little down in 2023, so maybe more of the sunlight reached the surface. So 2023 was not only record warm, but it was much warmer than what we would expect from global warming with an additional heat from El Nino. So that's the way that natural variability and global warming have combined. But your specific question about North, Northwest, Central India has another component which is much more directly related to global warming. And that is that the deserts that tend to warm relatively fast under global warming have in fact warmed. So Middle East and the dry Mediterranean region have warmed tremendously in the last 20, 30 years. Those winds have actually, that warming, actually has shifted the winds over the Arabian Sea during March, April, May. The winds are being pulled northward. That shift in the wind has started to warm the Arabian Sea. Plus, it is pumping in moisture into these parts that you asked about, North, Northwest, Pakistan, Central India, and so on. So not only warm air is coming, but humid air is coming. So the heat index has also gone up.
So, if I understand you correctly, sir, you're drawing a connection between the elevated temperatures in North India, Northwest India, North Central India, to the kind of increase in desert temperatures of Africa, I mean, the Middle East, and how they have increased the temperature of the air over the Arabian Sea, and that humid, warm air is bringing in heat and humidity into northern India, and therefore the temperatures are also rising. Is that an accurate summary of what you're saying?
Yes, exactly. So imagine that the winds would mostly come from the west. So you would get dry winds from Pakistan, Iran, Afghanistan into northwest India, central India. But now you are getting a component from the southwest, from the Arabian Sea, which is very humid. And humidity very rapidly adds to the misery when you have a heat wave, because the heat index jumps. Human body is less and less able to get rid of the heat by sweating if it is too humid, and so on. So that's exactly what you summarized.
And this kind of leads to that wet bulb temperature kind of phenomenon that people keep talking about.
Yes, so humidity goes up, then wet bulb temperature begins to become the issue, because how much any water body can evaporate or how much human body can get rid of the sweat, which is a cooling mechanism, is going to be heavily affected by the wet bulb temperature.
So you spoke earlier about El Nino and La Nina phenomenon, and how this La Nina is counter to El Nino. So what exactly is the dynamic between the two? And given that La Nina seems to be the more supportive of human existence in this heat, from what I as a layperson can make out, is there anything we can do to encourage more of this La Nina phenomenon to counter this El Nino?
I mean, you are right in one sense that for our region, La Nina, which is the opposite phase of the El Nino, when El Nino happens, the warm waters that are typically held up in the Western Pacific, so around New Guinea, Australia, and Indonesia, are dragged to the east towards Galapagos, and that affects the monsoon negatively and can affect the heat waves as well. When a La Nina happens, the temperatures around Galapagos are either
Just sorry to interrupt you. Said, this. What do you mean by Galapagos? Where exactly are the Galapagos?
yes. So Galapagos is on the equator, just off the South American coast of Ecuador. So it's
Okay.
in the far eastern Pacific.
Okay. Okay.
Okay. So you have Australia and New Guinea on the west, and Pacific Ocean is a huge ocean. So way in the east, you have Galapagos. I'm using Galapagos as a reference point because if I say Eastern Pacific, it may not be very obvious, but Galapagos, which is in the far east, around that, that's where you have lots of cold water, a lot of phytoplankton, a lot of fish, a lot of biodiversity. And that's the normal condition, cold waters and biodiversity. And in general, waters remain cold or they get colder than normal. So that is La Nina. And you're asking about whether we can encourage that water to get colder. Two things. One, you said maybe that's favorable for us. Yes. But remember that when it is cold water, typically you have no rain. Warm waters bring rain, which means South American coast on the west of South America and California and so on, they're very dry. They are dry regions. And Mayas, Incas, and so on actually went extinct because of these cold, dry climates. So if La Nina lasts for a long time, somebody will pay a price as well, whereas we may benefit a little bit. So you have to be careful who benefits and who gets hurt by any climate phenomenon. But the other question is, can we encourage it? As it turns out, because of the way the ocean and the winds work, with global warming, you see warming everywhere. I just mentioned the Middle East, the Arctic is warming very heavily, Indian Ocean is warming very rapidly, but the Eastern Pacific around Galapagos from the coast of Ecuador towards the dateline is actually been cooling for the last 30, 40 years. So the Eastern Pacific has remained colder than normal during this time. So that is creating a lot of problems. For example, you hear of heat waves and wildfires in the western US around California and so on. So nobody is a winner in this situation. Somebody loses and somebody loses in one season, somebody else loses in another season.
So you're saying, so this Galapagos region, which you say is being cooling for the last 30, 40 years, so they are sort of insulated from the global warming phenomenon if they are cooling.
Excellent question. It is not that they are insulated. It's the dynamics of how things work. Let's say the winds are blowing from the east around South America towards the west, towards Australia. If those winds get stronger with global warming, then the Galapagos region will remain cooler. Doesn't mean it is insulated. It just means that its response to global warming is affected by the winds, which are affected by the global warming to be stronger, and that makes it colder. So it is still a global warming response. You can think of it as a thermostat. So let's say when the Galapagos is cold, like during normal years or La Nina years, I said the ocean takes up the heat, and during La Nina, it releases the heat. So global warming makes the Galapagos and the oceans around that colder. That means ocean is taking up the heat during global warming. So in some ways, it is actually keeping the heat in the ocean, which means it is reduced in the atmosphere. So the warming rate of the atmosphere is actually slower than it could be if the ocean stopped taking up the heat. In fact, the ocean takes up over 90% of the additional energy we are trapping because of increased greenhouse gases.
Right. So I
Okay,
guess I suppose that's one reason why oceans are referred to as carbon sinks. Is that right, or is that something else?
no, it is related. So oceans are taking up carbon, about 25% of all that we emit. But that carbon is trapping so much more energy, which is what is causing global warming. 90% or more, a little bit more than 90% of that additional energy we are trapping is going into the ocean, which means oceans are warming like crazy. And the warming is going deeper and deeper. It used to be in the top few hundred meters, and now we can find warming in some regions as deep as 2 kilometers or 2,000 meters. So all the energy is staying in the ocean, in the system. It's not going to space.
Right.
That's what we have to worry about.
Right, right. So to come back to the Indian summer context, so we have, I mean, I had mentioned in the intro that more than 70 people have sort of died as a result of this heat wave conditions. So what are the public health implications of a sustained heat wave? You know, more than deaths, when there are also, I'm assuming other issues here. When is there like a threshold temperature above which heat strokes become more likely, a more regular incident in terms of public health hazard?
Yes, I mean, there are it's not just the heat, it's also the age group. Children are much more vulnerable to heat than, let's say, adults, and old people are much more vulnerable to the heat than the middle-aged people or adults of, 20 to 40, 50, let's say. So people who are inside are less vulnerable, of course, than people who are working outside, like farmers, vendors, construction workers, and so on. And humidity also makes a big difference. So it depends on whether you are in a humid coastal region like Mumbai or you are in the interior, somewhere dry.
So, before we move ahead to the next question, let's take a quick break. We'll be right back.
Technological acceleration is increasing exponentially. To make sense of this acceleration, we speak to scientists, business leaders, and policymakers on our new weekly podcast, The Interface. This podcast is hosted by John Xavier, the Hindu's technology editor, who will keep you informed about the dynamic technological landscape and the mindset needed to navigate this terrain. So tune in to The Interface on Spotify, Apple Podcast, or wherever you listen to your podcasts.
So, sir, I was just wondering, what are the public health implications of this kind of sustained heat wave conditions like we're seeing this year? I mean, is there like a threshold temperature above which heat strokes become an obvious public health hazard? Are there other risks as well?
Yes, again, remembering that we are always getting a heat wave season starting in March. Depending on the onset of the monsoon, it can even go into June in some places in the North India, for example. Right now, we have monsoon in the south, but heat waves in the north. So considering this, then you add what is called a chronic change. So background temperature increases. And the heat wave definitions are that it's always an exceedance. So whatever is the background temperature, if you exceed by a certain number of degrees, then you call it a heat wave. And then if you add humidity, the comfort level goes down because humid air makes it harder for the body to sweat out the heat. And considering all that, you have then the age group. So young infants and children are much more vulnerable, and old people are much more vulnerable. So in general, sustained heat waves, basically you think of the intensity of the heat wave, the scale, how large it is, and how often it comes. Then obviously you make these people more and more vulnerable. But then you have people who are working outside, farmers, construction workers, vendors on the streets. And if they are not careful, they may not be directly vulnerable, but they can become careless. And some of the election workers that died obviously were not given enough warning, or they didn't take enough care to meet the demands of hydration, being in the shade, and so on. So it's complicated, but in general, background warming is never good because then you exceed the thresholds very quickly.
Right. So basically, the very young, the very old, those who are working outdoors, and of course, I think those who already have certain morbidities, I think these are the categories who are at extra risk from heat wave conditions. One other question which came to my mind, I mean, we know in the context of climate change and higher temperatures, there has been a spate of forest fire incidents, not just in India, but all over the world. But this year, we've also seen a lot of fires breaking out in urban centers, not in forests or jungles, but in a place like Delhi, So what causes a higher frequency of fires breaking out in cities in the summer? How is that something we can explain?
There isn't any research to show that urban have shown any increase in the number or intensity as opposed to the wildfires. So my guess is that in urban centers, you always have material that can burn up. You have garbage piles, you have hutments, which are made of plastic and wood, which are vulnerable to sparks and so on. And you always have old trucks, diesel trucks running around, or people being a little careless with throwing out the cigarette butt and so on. So unless there is proof that it was started naturally, in wildfires, you typically have lightning being the major cause of starting fires. And then if you have a very hot day, like we have had this heat wave season, then you have obviously dried up the vegetation. And I think I mentioned before, it's something called vapor pressure deficit, where when you have very warm atmosphere, it's a very thirsty atmosphere, so it can hold much more water vapor. So it's like a sponge in that case. So when the leaves open their stomata to capture CO2, and they are trying to save the water vapor as much as possible, which have lifted with great difficulty from the roots. Then that loss is much higher if the temperature is warmer in the atmosphere. In that case, they begin to desiccate and get drier. So you have dry vegetation just sitting there and being vulnerable to natural sparks like lightning. And in urban centers, the same thing works as the urban vegetation can get dry as it is. They don't get as much water. And we have come out of the last monsoon, coming into this monsoon, which is fairly dry for 8-9 months. So this is a combination of human factors plus all the warming that basically sucks out the water vapor from everything, including soil and little ponds and backyards and so on.
Right. So this vapor pressure deficit, I think it could be a key factor in the higher number of fire incidents, I think, whether regardless of whether it's in the forest or in the urban centers, because there are dry vegetation in cities as well. Now, one last question, sir, before I let you go. So we have discussed the various dimensions of this heat wave condition, the public health implication, and so on. So in terms of, in the context of global efforts at climate mitigation, which is like a broader kind of a crisis, coming to India and this heat wave kind of a scenario, is there anything that the Indian government needs to do at the national level, at the state level, to counter such extreme heat waves and the related hazards?
India actually has been doing many things already. I myself have been involved in advisory councils of institute called Indian Institute of Tropical Meteorology, and now the Ocean Forecast Center in Hyderabad. And essentially, the first thing is to develop early warning so that a few days ahead, at least one day ahead, you have some inkling of the heat wave that is coming. And often they are not very local in the sense it doesn't tell you necessarily in Mumbai it's going to be in this neighborhood, because the vulnerabilities and the dangers are at neighborhoods, and general weather forecasts from 1 to 3 days, 3 to 10 days, these 2 to 4 have gotten much better. The other thing that has gotten much better is the National Disaster Management Agency, which is now coordinating much better with the India Meteorology Department to track the heat wave forecasts and warnings. And then, you have to set up shelters and hydration centers, public transportation for the public, and people who work outside have to be specially given proper warning. And, the last mile problems, it's not just a forecasting problem, to the last person on the street. You need some sort of an extension agency, like in agriculture, who have extension agents who talk to the farmers at various about various issues. So we are not there yet, but a lot of things have been done. And each year there are heat wave workshops held by the National Disaster Management Agency and by IMD. Things are being learned, and this year was way out of the scale in terms of where we reached, and the number of deaths is quite high. I think it was about 50 this year. So it's not just about how many people died, but it's about crop damage and a lot of things that vegetables may get damaged for the vendors, fruits, food, etc. So there's many issues, and India has to, it is playing a big role on the global stage in terms of participating in the mitigation efforts, renewables and afforestation and so on. And all this heat wave response, any response to these hazards is very local. It's an adaptation problem, not a mitigation problem. So it's about managing the unavoidable things that are already here, as opposed to mitigation, where you are trying to avoid the unmanageable things from coming. So mitigation is easier at the global scale, leadership is easier. But when India is sitting here and getting hit by warming elsewhere, heat waves coming from elsewhere, extreme weather coming from elsewhere, then it's harder to manage. But we have to do the best, in terms of urban green cover and not deforesting, and even rural areas, green cover has to be protected and water bodies have to be protected and so on.
Right, green cover has to be protected, water bodies have to be protected. I mean, these are important points. But I just read the other day one report about how there are so many buildings, like when we were talking about Gurgaon in Delhi, there's so many buildings made of glass, and there are new buildings in this kind of a climate which are made of glass, like multi-story, 30, 40 floors. completely made of glass. Like what kind of sense does it make to have glass high rises in India, North India?
So you touch on a very critical issue in terms of what is called a urban heat island effect, right? So you have all day sun heating everything, concrete warms up very fast, paved regions warm very fast. At night, they have to get rid of this energy as thermal radiation, but it doesn't go out because it keeps bouncing around between buildings. So there is a compromise. During the day, you think if you have a glass building, then you will need a lot of cooling energy. But at night, maybe glass is easier in terms of getting rid of the thermal energy. So I'm saying there have to be some optimization done where you are using natural light during the day with glass, let's say, and reducing energy consumption as well, as opposed to concrete buildings. So it is not just as simple as saying, don't use glass. There has to be more detailed urban planning, urban design, combined with natural light, reduce, natural circulation to reduce AC use, green cover that we talked about, plus, rooftop gardens, or you have white colored rooftops to get rid of the heat. So there are many urban design problems which are kind of complicated, but yes, we have to be very careful about every detail about what we are doing.
Right. Thank you so much, Professor Raghu. It was an absolute pleasure discussing this very important subject with you. And thank you so much for all your insights and observations. Hope to have you back sometime soon. Thank you.
Surely. My pleasure. Thank you.
In Focus will be back soon with analysis of the biggest news issues. In the meantime, you can find our podcast on Spotify, Apple Podcasts, Stitcher, and other platforms. Just search for In Focus by The Hindu. We'll see you soon.